Our topic was the reading instruction and scores within public and private schools. The public schools took the Think Alouds or TA, where teachers will think aloud while reading sections orally. Teachers will discuss what they are thinking about while they are reading to monitor comprehension within readers. This method slows down the reading process and allows students to monitor their thinking as they read. The private school students took the Directed Reading Thinking Activity (DRTA) comprehension strategy that encourages students to ask questions about a given text, make predictions, and then read the text to confirm or deny their predictions. The DRTA helps to strengthen reading and critical thinking skills. We plan on creating a 2-sample independent t-test to compare the TA method and the DRTA method and find out which one was better based off the pre- and post-test scores.
While we describe our data, our types of variables we use were instructions, pre and post, type of school and calendar, and our new variable that we named diff. Instructions is categorical, and it indicates the type of instruction. Pre and post is continuous, and that represents pre and post reading scores. Type of school and calendar is categorical, and that is just public or private. And then year-round or traditional. New variable is continuous, and that is calculated as the difference between post and pre scores as a measure of improvement. Our new variable we introduced as diff is to quantify the improvement in scores calculated as the difference between post and pre scores. Our p-value was 0.1680, and our alpha value was 0.05. This is a diagram of our description of data graph. For our DRTA, our mean was 6.3, our standard deviation was 5.88, our minimum was -12, and our maximum was 18. For our TA, our mean was 8.95. Our standard deviation was 6.0391. Our minimum was -3, and our maximum was 17. For our pooled value, our mean was -2.65. Our standard deviation was 5.9629. Continuing the graph, for our pooled method, our t-value was -1.41, and our PR was less than t, so it was 0.1680.
For the statistical methodology of the project, we began by writing our SAS code. And in the process of writing our SAS code, we determined that we must create a new variable that will examine the difference between the pre-test reading scores and the post-test reading scores for each type of reading instruction that were given to the students. We decided we needed this new variable, which was labeled diff in the SAS code, because the primary research question that we were examining was if there was a statistical significant difference in effectiveness between the two types of reading instruction, and in order to examine the difference between the two, we needed to subtract one from the other and examine the difference. We created a null and alternate hypothesis for what we were looking into in our investigation. Our null hypothesis, HO, was that there was no difference in effectiveness between the TA and DRTA types of reading instruction on reading scores. And then the alternate hypothesis, HA, is that there is a difference in effectiveness between the TA and DRTA types of reading instruction on the students' reading scores. Based upon our data, we ran a 2-independent sample t-test in SAS. The reason we did this is because a 2-independent sample t-test calls for 2 variables that have no direct effect or impact on one another, but the sample means of both still need to be compared to one another. And in this instance, the pre-test scores of students and the post-test scores of students do not directly have an impact or effect on one another because they're taken at separate times after a certain amount of instruction has been given before each, but they still need to be compared to one another in order to determine if the instruction given in between each type of test is more effective than the other. We determined that some of the variables that were given and included in the data set were not necessarily of importance when considering examining the data and considering what answers our research question. For example, there was one variable given in the data set called calendar year that was listed for each of the scores alongside the data, and calendar year was not necessary when considering and examining the data because it didn't impact in any way the reading scores, type of instruction, or the outcome of the two. After examining our SAS output, we concluded that our t-test fails some of the assumptions necessary to continue with the investigation. With a two-independent sample t-test, there are 3 types of assumptions that a test needs to pass in order to be considered valid and to move forward in examining the test. If a test cannot pass all 3 assumptions, then it is not considered to be valid. And as talked about in the next slide, we'll list out which 3 assumptions and which one in particular our test failed. But after looking at the output, we did conclude that it did not pass all 3, it failed the normality assumption. Additionally, after running the SAS code and seeing the output, we use the p-value to determine that if we must fail to reject the null hypothesis, concluding that our data is not statistically significant in difference between the 2 types of instruction. We typically use the alpha value of 0.05 as a comparison value for the p-value. Our p-value, as stated later, was large enough over 0.05 that it showed that there was no statistical significant difference in effectiveness between the 2 types of instructions, and therefore we could not reject the null hypothesis, and we were not able to accept that there would be a difference in effectiveness.
One of the first things you want to do with your 2 independent sample t-test is address the 3 assumptions, these 3 being randomness, normality, and that of equal variance. So with the first assumption of randomness, we came to the conclusion that this was not a random sample because the TA method is specifically tested in public schools only, while the DRTA is exclusively tested in the private schools. For the second assumption of normality, we said that this was not perfectly normal by looking at the histograms and the box plots below. But as we stated in class, it was good enough. The third assumption is equal variance, and when you run the SAS code, it does state that the variances are equal, also giving you a pooled DF of 38. So the first step we took was creating a new variable. We named this variable diff, and this measured the differences between the post score and pre-score as stated.
We used proc print to analyze each individual student and the difference between their pre-test reading score and post-test reading score. We used a 2 independent sample t-test to see if the average difference for TA was significantly higher than the average difference for DRTA. Our null hypothesis was equal to 0. We used a 2-sided t-test and our alpha was equal to 0.05.
In conclusion, due to the p-value that we generated of 0.168 with an alpha value of 0.05 for reference, we fail to reject the null hypothesis, meaning that there is no statistically significant difference between the reading instruction types and how they affect students' reading scores. Within real-world application, our findings would be used to determine if one type of reading method should be promoted over another for more accurate reading scores among students. But due to there being no statistically significant difference, we cannot say that the TA method is more effective than the DRTA, and vice versa. In regards to the p-value that we are using to measure the significance of our data, a p-value measures the probability of obtaining the observed results, assuming that the null hypothesis is true. Which means in every experiment, we must assume that whatever the null hypothesis is automatically true, and the p-value works to disprove that in order to accept the alternate hypothesis. The lower the p-value is, the greater the statistical significance of the observed difference. In this instance, because our reference value was an alpha of 0.05 and 0.168 is much greater than 0.05, that means there is less statistical significance in the observed difference. And what this means is that we are not allowed to reject the null hypothesis, which means we must accept it, that there is no difference in effectiveness in regards to back to the real world application. This means in our findings that one method isn't more effective or better than the other, and we therefore cannot recommend promoting one over the other in regards to students learning in their reading instruction. For a more accurate observation, we would have created the dataset to be completely random in both selection and assignment, as well as included more observations until the data was undoubtedly normal. The reason for the randomness is because when we were initially given the data set, what we noticed was that the TA method was only applied to public schools and the DRTA method was only applied to private schools, but there was no randomness between the assignment of the methods versus schools and the type of school that it was assigned to. And in this way, we cannot then say that the randomness assumption was completed, and so our trial would not be able to go forth. In regards to the normality, as we looked at the graphs that were generated by SAS, we noticed that while the bell curve was relatively normal, that it was quote unquote good enough. It was not normal enough to be entirely comfortable with being able to pass the normality assumption. That's one of the three. And so what we would have liked to have done was observed more students and applied the two different methods to more students to collect more data, because that way, the more data we have, the more normal our bell curve is likely to be, and the more likely that we'd be able to pass the normality assumption of our test. But this concludes the presentation of our results for reading instruction, and thank you so much for watching.